All right, so this is basic Mendelian genetics. This is just you have dominant, you have recessive traits, and you are curious on where it is you got your genes from. Well, geneticists will use this structure called a pedigree. It's a family tree, and females are represented by circles, and males are represented by squares. Now, if your square or circle is filled in, that means you actually have the disorder. If it is empty, that means you are just a normal male or female. So when you're looking at a pedigree, you first need to figure out what is the recessive trait and what is the dominant trait. When we're talking about being an Oompa Loompa means you are recessive. And normal skin pigmentation, that's fine. You look like a normal person. So we're just going to use a normal person to be a big A, and an Oompa is a little a. So in order for you to be an Oompa Loompa, that means you have to be homozygous recessive. And by looking at this family tree, you can immediately go in and fill in where the darkened shapes are with a little a, little a. And if you don't have a shaded in circle or square, you know that at least one of those has to be a dominant gene. And the trick is to figure out what the missing gene could possibly be. So the way these are organized, you start at the very top of the family tree, and you see a circle and a square. That's mom. They are connected to dad. So mom and dad, they have 1, 2, 3 children. They have 2 girls, because you have 2 circles, and 1 boy, which is a square. One of the girls is an Oompa Loompa. So let's just think about regular genetics. You have to get a gene from both your mom and your dad. So this gene has to come from mom or dad, and this gene has to come from mom or dad. That immediately tells you that the missing gene has to be a little a. So you can kind of play detective and work backwards to figure out what the missing genes are. Now, if you go down to the boy, on the other hand, you have an A and you have a blank. Well, where did that A come from? Well, we're not sure. That A could have come from mom or dad or mom. But the question is, what is this one? Well, it still could be a capital A or little bitty a. In the same case with the daughter next to it. This A has to come from either mom or dad. But the question is, what is the missing gene? That could also be an A or a B. A capital A or a B. The only way you're going to be able to tell what these two missing genes are going to be is when they get married, like this person did here, to this guy, and they had a kid. And they have a kid that is an Oompa Loompa, so that means their missing gene has to be a little a. So you can kind of tell that that little a either came from mom or dad. But we're still concerned about this one right here. This one still can be either one. We're not really sure. The only way that we can tell what this particular kid is when that kid gets married to somebody and they started having kids. So in this particular case, I would put a question mark, because it's still unknown until this person gets married and has children of his own. Then you would be able to tell, based upon what his kids look like, what that would be. Let's try one more. This one's a big one. Okay, so remember we're talking big A and little a. That's normal blood or normal skin, and this one means you're an Oompa. Very first thing you can do, immediately what you can do, is if you see a shaded in square or shaded in circle, you can immediately go in and fill in recessive, 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 recessive. And you know that every single one of the clear circles or squares, or it would have to have at least one dominant gene. Because remember, you're going to be visible if you have at least one dominant gene. Now the trick is trying to fill in all of the missing genes based upon looking at this family tree. Okay, so let's start with the original parents. Let me change my colors here, okay? So you have dad who's an Oompa Loompa and mom who is not. They have 1, 2, 3, oops, sorry, that is not 3 kids. They have 1 daughter, 1 son who are Oompa Loompa, and 1 daughter. This line right here means that this person married and went and had kids of their own. Okay, so if that means you have 2 Oompa Loompas in the family, well, dad can only give A's, and mom has to give a little a as well. So that makes mom's a little a. So this one right here, capital A right here, that capital A has to come from mom. So that means dad has to provide a lowercase a. Now, like I said, this son married this daughter. This son married this girl, not daughter, and they had kids of their own. They actually had 1, 2, 3, 4, 5 children. Okay, they have Oompa Loompas in there. So that means dad can give a, little a. Mom can give either a big A, and she has to give a little a because they have Oompa Loompas. You remember, you get 1 from mom and 1 from dad. So mom has to give that recessive gene. Let's go to the second child. Second child, you have 1 big A, and you got to remember, dad has to give the little a. Child 3, we already know because it is an Oompa Loompa, little a, little a. Child 4 has 1 big A, that comes from mom. And remember, dad can only give little a's. And then the last daughter is an Oompa Loompa. Okay, now this daughter marries this guy right here. So we need to figure out what his missing gene is. Well, we look down here, and we see they also have an Oompa Loompa child. So that means that little a has to come from the father. And if they get a big A, this son gets a big A, has to come from here. That means mom can only give a little a. Let's do the middle daughter here, number 3. This Oompa Loompa marries this guy, and they have 1, 2, 3, 4 children. All of them have appear to be normal, but so the capital A's all have to come from this one right here. That's the only way. Well, it could also be. Could also, I don't know, this might be tricky, okay, because dad has to give that, and, well, I don't know, this could be that one, Or it could be this one. This one right here is still one of the ones that I would put A and a question mark, because it's still undetermined. So this one would be definitely an A and a question mark. And let's go to the last one over here. We have this Oompa Loompa marries this normal girl. Well, this one's pretty easy because they have 2 Oompa Loompa daughters. That means this parent also has that recessive A. And for this one right here, well, that comes from here, and that means Dad has to give that little A. Some of these are, some of them can be pretty tricky, especially, I would say, the most tricky one right now was this one right here. But if you take your time and you use rationalized thinking, remembering that each of the offspring, they have to get 1 gene from mom and 1 gene from dad. So good luck with the pedigree problems. Don't get frustrated. Just think it through logically.